Hi, everyone. Thank you for being here. My name is Christos Melissourgos, and I'm the CTO of Voice Logica. What I hope in the next 15 minutes is to give you a description of how a voice agent works in production, where it breaks, where it doesn't, and what we have learned the hard way. For the last 2 years, we have been building and running voice AI agents in production, not demos, actual deployments, handling thousands of calls daily for businesses across collection, e-commerce, booking, and support. And in those 2 years, we have seen a lot of things break. Some funny, some not so, some kind of serious. And we have discovered that they share some common patterns. They map to the 5 layers that we have figured out are that a voice agent has, which are scope, voice, brain, hands, loop. All right. So the first layer, I'm gonna tell you some stories of our experience and what we have experienced while we were building voice agents. Sorry for my trembling, I'm not so good in public speaking. So I'm gonna tell you some stories. For example, an AI agent that actually booked appointments for a customer, appointments that it shouldn't have booked because the slots didn't exist. One agent that kept interrupting the people mid-sentence because there was a TV in the background noise. An agent that broke its own booking rules every Monday, and one agent that hallucinated answers because they had an FAQ of that was 3 months out of date. The first scope, the first layer is the scope. Scope is usually boring. Nobody gets excited about scoping the agent. Everyone gets excited about the LLM, the voice, the cool stuff. But scope is where most agents get broken. Most agents are broken before they take their first call. Remember the agent that was breaking his own rules every Monday? So what happened was we have a client, an accounting firm, and they wanted one agent to handle everything, to handle routing calls between sales, marketing, and accountants, answering accounting questions from individuals and companies, and also booking appointments for the individuals. And on top of that, on top of all that, enforce the booking rules. For example, like no bookings on Office on Mondays, only Tuesdays and Thursdays. Certain partners are available on certain days. That's what the agent had to do. And now some of you maybe are wondering why the booking system didn't just enforce that. The answer is it didn't. Their API would happily accept a Monday booking, although they gave us instruction not to for the agent, and would even return us incomplete data. So the rules of the booking had to stay somewhere, and that somewhere was the agent. So the agent had to do all that, like the routing, the answering to questions, the booking rules. So what we did is we built the agent, and it was running fine for the first few weeks. And as it was going, we noticed some things. Some Monday bookings were slipping through, calls got routed to the wrong department, and also the agent forgetting which human agent, which partner did what. And the funny thing is, when we saw that, is that we were running GPT 5.1 at the time, which is not a cheap model, not a small model. It was the best model available for that time, and it was still struggling. So the issue there wasn't intelligence. The model was intelligent enough. It was attention. We had put too many rules into an agent, and the more rules you place into a prompt, the less weight each rule carries. So we had to think of a way to make it better. So because that's the definition of a bad scope. A bad scope isn't just one big failure. It's a lot of small issues that take place, making it not functional. So what we've decided is like to scope ruthlessly. Of course, you can push as many things as you want into a prompt to see where it fails. That's how you find the limits of the voice agent. Voice agent also, we need low latency, so the more data you put, the more time it takes to respond, and we need like sub 1 second response. So we needed to actually scope the agent and split the agent. So the agent had to do one specific thing. So what I tell my team now is like, stop trying to patch and fix it, because the customers, kept emailing us that we want one agent to handle everything, so it's better for organizing. But we figured out that if you have one agent that tries to do many things, it will most likely fail. So we built multiple agents in order to tackle this. The second layer is the voice. The voice is what the agent actually hears and what it can understand. Remember the agent that I mentioned that kept interrupting the caller mid-sentence? So we were running an outbound campaign for an exhibition, and we were calling people in order to ask them if they want to attend an event or not. So we were calling them, and we were saying, we were introducing ourselves as an AI agent, and we were asking, do you want to attend the event? And we were doing that on Sundays. On Sundays, most of the people are home, and they have TV on the background. So this is when we noticed this thing. And the agent was interrupting the person because the person on the TV stopped talking, and there was this collision between who spoke and the background noise. So when one person of our team saw that, he tried, the first thing to try to fix is the prompt. Like, if you hear someone in the background, don't pay attention, but this isn't the correct fix. What we have figured out in order to tackle this problem is build two tools. The first is speaker lock-on, technically the diarization. So whenever we establish a call with someone, we lock on to the person speaking, and we filter out everyone else, every other packet that comes that's not from the same person, it gets filtered out. So now, whatever we have, like children playing in the room, someone speaking, TV, all gone. The AI focuses on the person that's actually speaking. The second is the skip turn. Sometimes if you have used voice agents, you speak to a voice agent and you stop because you want to think something, or you're like saying a number 698, and then if you make a small pause, the agent interrupts you and says, okay, please continue. And we have found that this is really frustrating. So we built an extra tool that checks the dialogue, the current dialogue, checks what the user just said, and if the user hasn't completed speaking, saying his own sentence, then we just give him some seconds to breathe. So it turns out to be more natural, more not so robotic dialogue. So that's the two tools that we have built in order to tackle. In order to tackle the voice problem. The third rule is the brain. It's kind of exciting, and it's what you discussed earlier about the vectors and all that. So what we usually have when we build an agent, we take the FAQ from the client, we feed it to the prompt, and we create vectors. We use a low latency vector model because we want sub 200 milliseconds to get the response, because most vector models take a lot of time to, to create the vector and then the embedding and then fetch with cosine similarity the other vectors. So the issue here is that we had a client, remember the client that responded with hallucinated an answer of a document that was 3 months out of date. So now another case is that we had this client, an e-shop, that had given us a lot of FAQ, like documents of return policy, shipping options, a lot of actual things. So we fixed the prompt, we built the prompt, we create the vectors, and we just deployed it. What happened is, after some time, the people updated their policy, but no one actually went to update the agent, because the agent wasn't in their mind a thing where you should also update. Because why should it? If you come to think about it, the agent should auto get the new policies and everything. Otherwise, it's just another part-time job that you have to do. So in order to tackle all this, because this was starting to become a problem that every company had after some time, after like 2-3 months usually, is that we built 2 tools. One tool is like we create the vectors from a document or from a website, and we have an interval that the AI or like a service checks the website if it has changed its content. If it changed its content, then we retrieve the content of the new website or the new policy or the new doc. We remove the previous one, and we recreate the vectors so the knowledge is always on sync. The other part, which I think is like the smartest one, is that we created the tool. So remember I said our agent does call transferring. So when you ask, transfer me to sales, the agent will transfer you to sales. Most AI agents stop there. R does not. R stays in the call, listens to the conversation between the human agent and the customer. At the end of the call, creates knowledge files, knowledge questions and answers, and then feeds it back to the knowledge file that we have for that specific agent. So that's how we have always the most recent and valid information without the businessman or businesswoman having to do anything. Okay, now is the hands. It was about the example that I told you that the AI told the customer that his spot was booked, but it actually wasn't. So we have another client, a chain of fitness gyms, that we have our voice agent handle the bookings. So you call the fitness studio and you say, I want the booking tomorrow at 7. The AI checks the availability and finds the slots, confirms, and supposedly, books you an event, books you a slot. This is actually a tool call in AI, the tool calls. If you have run AI agents or voice agents, but I think it happens the same with normal agents, like in completion, sometimes tools don't fire. So the AI may have said the person that, you know what, okay, your booking is complete, but the person goes there, shows up, and they see that they have no booking. This is a really hit on the trust of the agent. So their client is complaining to our customer, and their customers obviously are complaining to us because their agent did the thing wrong. So in order to tackle also this problem, what we did is have an extra agent post-call, after the call, review the tools that were supposed to fire, did the schedule book appointment fire? If not, fire it now. If the slot is already captured from someone else, then alert the client, our client, to let them know that, we had this issue, you have to resolve this. And that's how now the customers, don't even know that something went wrong with the agent. Because the tool calls for me, are the most important parts of a voice agent, because they do create orders, book appointments, most of the things that actually interact with the real world. Now we have the fifth layer, which is the loop. Whenever we deploy an agent, this is not the end of our cooperation with the business. When we deploy it, it's actually like the starting line of a new project. Because the things that the first day the agent works fine, but after month 3, some other issues may occur, like new customer behavior or new questions. So remember the Q&A that did the tool checking to make sure that the tools were fired in the previous example? We have that same agent actually review every call, flag what issues the call might have, and then we review them weekly, because we might come across problems. For example, if multiple people have the same question after some time, it means there is a content gap, so we have to update the brain. If the person kept telling people kept telling the agent, please stop talking, and the agent didn't listen, then we have a voice problem. If we see that many calls get routed while they shouldn't, then we have a scope problem. So with this tool, we are able to always be on the loop and be careful of new issues that may arise while you have an agent on production. So these are the 5 layers: scope, voice, brain, hands, loop. And this, in my opinion, after running and building all these agents, I think this is what a good voice agent is set up with. And it's not just the LLM. We always have to look for all these 5, which makes it easier to locate which part we have to fix in every production agent that we deploy. Thank you.